Hello class. In this example I'm going to show you how to run a simple linear regression using the data analysis tool pack in Excel. In this example I am using the job satisfaction file for chapter 14. It's a very small data file that contains job satisfaction ratings before and after some job satisfaction improvement program. I don't know what the scaling is in terms of what these numbers mean, what's low and what's high. I'm assuming lower numbers mean less job satisfaction and higher numbers mean more job satisfaction. In this particular example, there's a sample of 10 workers. And one little trick I like to do with correlations, and specifically regression analysis, is to specify my x and my y variables ahead of time so it makes the identification and clicking using the tool pack a lot easier. And this easiest way to do that is to identify your x and your y variables and just simply type in the letter X, and I always put it in parentheses, and the letter Y right into your column names. Because all you need to do now is then go to the data ribbon, data analysis, select regression, click OK. Now it's asking us now for our Y range and our X range. Well, we know that our Y range is right here, and we know that our X range is right here, because we put our X and our Y in our columns names. That easy. Always check the box for labels because we included them when we highlighted our selections. We don't need to check the box for constant and zero. We'll go ahead and ask for a confidence interval. We'll put our output in a new worksheet, and then just check the box for everything here, including a normal probability plot, which I will warn you is not 100% accurate, but visually it is, and I'll show you that in a moment. So that's it. That's all you have to do is specify your X and Y's. Just click, 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 and click OK, and then you get this whole bunch of output here instantly. Now you might want to widen your columns here so you can see what's going on. So what you need to pay attention to first here is your regression statistics, your multiple R, but specifically your R squared. Okay. Basically, this is the same as a correlation. However, what this is saying is that there is a moderate but positive relationship between the before and after job satisfaction ratings. But the next thing you need to pay attention to is the significance level here for F. Okay, basically what this is saying that the entire regression model is statistically significant because it is less than 0.05. Now that's a big deal. If there were more independent variables or more X variables, you will still want to look at the overall model to see if it's significant. However, the next thing you need to go down to is the p-value here. And specifically, here's our X value. Again, the numbers are going to be identical because there is only one independent variable. If there were more independent variables, they would be listed below, and each would have their own subsequent p-value, and not all p-values would be statistically significant. So that's very important to the concept of the overall model. You could have an overall model that's significant, but then have specific X variables that are not significant, and that's telling you basically the strength of which independent variables are influencing the relationship to the Y or dependent variable more than one or another. Now here's that normal probability plot. What's important about this is to look to see if there's a diagonal line here. This is basically saying, is your data normally distributed? Does it follow the normal curve? And by doing so, it will have a diagonal line. Okay. One way to look at it, if you want to do this, this isn't very normal data. So visually, this normal probability plot through the tool pack is correct. However, it's not. It's missing the z-scores on the bottom here. Just to tell you what that looks like, if I was to create a normal probability plot, using phstat. And this is how easy this program is, and do this for my y and click OK. Basically, you can see here, the normal probability plots are visually identical. The difference here is this is plotting by a percentile, whereas phstat is giving you the z value. And basically this is off a series of proportions and z values that are calculated. phstat does it for you. Excel data analysis toolpack does not. But that's okay. Visually you're getting the same picture, and that's all you need to really be concerned about. Here's basically a plot of your x and your y variable. Again, not a very strong relationship because there would be more of a straight line. And then here's your residual plot. And again, we see a lot of values above and below that 0. So one last thing to pay attention to in the output here is your slope. Okay, that's going to be this number here. You don't really need to pay attention to the intercept. The slope, though, is important. The slope of a line indicates the number of units variable y changes as variable x changes by 1 unit. So basically what this is saying is that for every 1 unit change in job satisfaction after the job satisfaction program, you can expect a 0.61 unit change or increase in job satisfaction. That's all that's saying. So okay, that's it. That is a simple linear regression using a data analysis toolpack, and with a little caveat about the normal probability plot and how to check it with phstat 2.